A child slides down a slide with a 34-degree incline, and at the bottom, her speed is precisely half what it would have been if the slide had been frictionless. Calculate the coefficient of kinetic friction between the slide and the child. Okay, so let's first start off by drawing a diagram. So our diagram is going to look something like this. Okay, so here we have all the forces acting on the child. So we have the normal force, which is perpendicular to this new y direction. So keep in mind, when problems are talking about inclines, they essentially mean that we rotated our original xy plane, which would normally look like this. We essentially rotated it 34 degrees. So now our new x direction becomes this hypotenuse on this triangle, right? This whole thing's a right triangle. And then our new y direction becomes this direction perpendicular to the hypotenuse. Okay, so now we have our x and y components of force. This is our x component of force, and this is our y component of force. So we'll define downwards here to be negative, and we'll define upwards to be positive. And similarly, we'll define rightwards to be positive and leftwards to be negative. So we see that we know that the normal force is going to be of the same magnitude as this y force, but in the opposite direction, right? And same thing, yeah, so this normal force is going to be same magnitude as this y force. And so we need the coefficient of kinetic friction, right? And we can calculate that with the formula, the force of kinetic friction is equal to the coefficient of kinetic friction times the normal force. Okay, and the normal force, the magnitude of the normal force is going to be equal to the magnitude of the y force. And the y force, right, well, using trigonometry, we see that the y force is going to be negative mg cosine 34 degrees. Right, so negative mg cosine 34 degrees. So now the normal force is going to have that same magnitude, but in the opposite positive direction. So the normal force is going to be equal to positive mg cosine 34 degrees. So this is the value we found for the normal force. Okay, now we need to find the acceleration, right? So let's first look at the net x forces. So the net x force, right, that's just going to be f of g of x minus this kinetic friction force. And by Newton's second law, this is equal to mass times acceleration. Now, remember, we calculated normal force, right? We calculated normal force to be equal to mg cosine 34 degrees. So, since normal force is equal to mg cosine 34 degrees, the kinetic force is going to be mg cosine 34 degrees times the coefficient of the coefficient of kinetic friction, right? And this f of g of x, right? We can use trigonometry here. So we look at this right triangle. So f of g of x, this is going to be mg sine 34 degrees, right? So we can substitute all these values in, and then we can cancel all of the masses to find acceleration. Okay, so we've substituted these values in, and I factored out the mg's. So we have mg times sine 34 degrees minus the coefficient of kinetic friction times cosine 34 degrees is equal to mass times acceleration. Now we can cancel the mg's to get acceleration is equal to this part, right? So this part just without the m. Okay, so this is the acceleration of the child when she experiences friction, right? This is her acceleration along this incline if she experiences kinetic friction. So we can use this acceleration, since we don't know time or anything, it would be best to use the formula where we have final velocity squared, right? The kinematic equation. So we can substitute this in for A, and then we can maybe get an equation for velocity if she experiences friction. So by the kinematic equation, we have V, we'll call the velocity with friction f of 1. So we have V f of 1 squared is equal to her initial velocity, which is 0, 0 squared, plus 2 times her acceleration times her displacement. So we'll substitute this in for A, and then we'll get 2 ag times, and then we'll have this displacement, right? So the displacement is basically just going to be the distance she travels along this incline. So we'll just call this L. So we'll call L the distance she travels. So L, and then we'll multiply, oh wait, let me get the acceleration out. So 2gl, and then the acceleration is going to be sine 34 degrees minus the coefficient of kinetic friction times cosine 34 degrees. Okay, so this is her final velocity squared if she experiences kinetic friction. So now all we need to do is find the final velocity if she does not experience kinetic friction, and then we'll create an equation between the two of them to solve for this coefficient of kinetic friction. Okay, so how do we calculate the velocity without friction, right? Well, to do that, what we're going to need is her acceleration. And that's all we need because we have her displacement as L, and we know her initial velocity is 0. So all we need now is her acceleration. Well, keep in mind, right, if she isn't experiencing any velocity, then she isn't experiencing this kinetic friction force. So by Newton's second law, we have the net force on x is just equal to this Fg of x. And that's going to be equal to mg sine 34 degrees. And this is equal to ma, right? So her acceleration, if she does not experience friction, is just going to be g sine 34 degrees. So, and then her displacement is still going to stay the same as L. So her velocity squared without friction is just going to be v2 squared is equal to 2gl times sine 34 degrees. Now, what does the problem tell us, right? Well, the problem basically says that if she travels without friction, that speed is going to be twice her speed if she travels with friction. So what we can say is that v2 squared, or v2 by itself, is equal to 2 times v1. And we can square both of these sides to say v2 squared is equal to 2v1 squared, which equals 4v1 squared. Okay, cool. So now all we need to do is substitute equate our expressions for v1 and v2, and then we need to solve for the coefficient of kinetic friction. Okay, so we have this equation. These GLs are going to cancel out, and then the 2 will be canceled, and this will become 4. So then we have, this is going to be sine 34 over 4, right, this part, and then we'll subtract 4, so then we'll have negative 3 sine 34 degrees over 4 is equal to negative coefficient of kinetic friction times cosine 34 degrees. So this means that the coefficient of kinetic friction is going to be 3/4 times the tan of 34 degrees, right? Because we're dividing sine by cosine. So that's just going to be tan. So coefficient of kinetic friction is going to be 0.75, or 3/4 times tan of 34 degrees. And this approximately equals 0.51. So this is our final answer for the coefficient of kinetic friction.